Imagine gliding through a near vacuum tube at speeds exceeding jet airliners, feeling the G-forces as you zoom past cityscapes in a flash. That's the tantalizing vision of the Hyperloop, a futuristic subway on steroids, where pods levitate on air cushions inside a low-pressure tube, minimizing friction and propelling you at mind-blowing velocities. Okay, so it does sound like something out of a Star Wars movie, but the Hyperloop is a reality with some serious potential. It's a game changer for business, tourism, and even disaster relief. Join us on this video and let's dive into the Hyperloop, its technology, challenges, and the question on everyone's mind. When will it become a reality? So let's get started. The Hyperloop concept was popularized by Elon Musk in 2013, envisioning pods traveling through near-vacuum tubes at speeds of up to 700 miles per hour. And since Musk's proposal, companies like Virgin Hyperloop and Hyperloop Transportation Technologies have taken up the mantle, developing test tracks and prototypes. The idea to drastically reduce travel time between major cities, from the deserts of Nevada to the Arabian Peninsula, Dubai to Abu Dhabi in 12 minutes, Los Angeles to San Francisco in 30 minutes. These aren't just dreams, but goals on the drawing board. Now let's talk about the science behind Hyperloops. Bringing the Hyperloop from concept to reality involves groundbreaking advancements in engineering and physics. At its core, it works by using a combination of magnetic levitation and vacuum-sealed tubes to transport passengers and cargo at high speeds. Instead of traveling on tracks, the Hyperloop pods levitate above the track, reducing friction and allowing them to travel at supersonic speeds. The basic concept is to create a low-pressure tube in which pods or capsules can travel at high speeds without friction or air resistance. This tube is then pumped with air, or a vacuum is created, to reduce air resistance and, therefore, increase speed. This technology is similar to what is used in high-speed trains, but it is much more efficient, which means the pods can travel at much higher speeds. To put this into perspective, the fastest high-speed trains today, like Japan's Shinkansen, top out at speeds of 200 miles per hour. Commercial flights average 500 to 600 miles per hour, and Hyperloop aims to shatter these benchmarks, all while slashing carbon emissions and congestion. Additionally, the Hyperloop system is designed to be energy efficient, with solar panels providing the energy needed to power the propulsion system. This means that the technology is not only faster and more efficient than traditional modes of transportation, but also environmentally friendly. But the road to revolution is rarely smooth. From creating vacuum-sealed tubes spanning hundreds of miles at near supersonic speeds, the technical challenges are immense. And even beyond the tech, there's the question of integration. How will Hyperloop stations connect with existing transport networks? The engineering required to maintain a near-vacuum state over hundreds of miles of tube is unprecedented, highlighting the need for massive infrastructure investments. Concerns about the cost of construction, land acquisition, and regulatory approval loom large, with estimates running into billions of dollars. Remember Virgin Hyperloop, the company backed by Richard Branson? They were a major player in the race and made headlines as it conducted the first human trial of Hyperloop in November 2020 at its test site in Las Vegas. However, recently the company has laid off most of its operations. This serves as a stark reminder of the immense financial and technical hurdles involved. Moreover, the question of passenger safety, especially in emergencies such as power outages or breaches in the tube, remains a critical area for development. And not to mention navigating the complex web of land rights and environmental regulations. Yet, despite the setbacks, the allure of the Hyperloop remains. Several other companies are still vying to make it a reality, with test runs pushing the boundaries of speed and technology. One such example is Transpod Hyperloop. This project is being developed in Canada and aims to create a Hyperloop system that can transport passengers and cargo between major cities in Canada, such as Toronto and Montreal, in just an hour. And we also have TUM Hyperloop, the brainchild of Technical University of Munich. The company is currently building up the technology. So, is Hyperloop a future of transportation or just a pipe dream? Will it redefine global transportation, or will the technical, financial, and regulatory hurdles prove too high to overcome? Well, this debate might be continued for a long time, with experts divided on whether the Hyperloop will become an integral part of our transportation infrastructure or remain an ambitious dream. But the answer lies in ongoing research, development, and the willingness of societies to invest in a radically new form of transportation. And let's dream big for a moment. A world with Hyperloop could mean more than just fast travel. It could reshape cities, reduce urban sprawl, and significantly cut transport-related carbon emissions, contributing to the fight against climate change. With cities like Dubai exploring Hyperloop routes, the question isn't if it will happen, but when. In fact, it's a reminder that the future of transportation might not involve wheels and wings, but sleek pods zooming through near-vacuum tubes. So, what do you think about Hyperloop, future of transport, or a fascinating fantasy? Let us know in the comments below, and don't forget to like and subscribe for more deep dives into the world of tomorrow. Thank you for watching.